Hello friends, welcome to Independent Learning. My name is Raj Shah, and in this video we are continuing with the chapter triangles. Okay, in the previous video we saw the theorems on isosceles triangle 30 60 90, 45 45 90, and theorem on median. Okay, so in this video we are continuing with the chapter, and will be going to do theorems on angle perpendicular bisector theorem and angle bisector theorem. Okay, so the first one, which says, okay, perpendicular bisector theorem, it says that every point on the perpendicular bisector. So first of all, you know what is a perpendicular line? If you have a segment, okay, any segment AB, or let's say PQ, this is a segment with point P and Q. So this is the segment, and if I say that I'm drawing a perpendicular to this, so perpendicular means just this, which is making an angle of 90 degree with segment PQ. So that is perpendicular. But what is perpendicular bisector? So bisector means it is dividing the segments into two parts. Like for example here, this line, okay, this line is dividing AB into equal parts, which is AM and BM, they both are equal. So that's what the meaning of bisector is. Okay, so the theorem says, so I hope you have understood what is the meaning of perpendicular bisector. Okay, therefore now let's see. So every point on the perpendicular bisector, so this is the perpendicular bisector we have drawn on segment AB. Okay, and every point on the perpendicular bisector, let's say that is P, any point P, okay, of a segment is equidistant from the endpoints of the segment. So this point, we have to prove that this point which is on the perpendicular bisector is at equal distance from the endpoints of the segment. I hope you have understood this. Endpoints of the segments, that means we have to prove that PA is equal to PB. Yes or no? What are we supposed to prove? That every point on the perpendicular bisector, so which, let's say that point is P, okay, that point should be at equal distance or equidistant from the endpoints of the segment. So this is what we need to prove. So we have to prove that PA is congruent to PB. Okay, so I hope you have understood this. PA should be congruent to PB, we need to prove. Okay, let's see what is given. Let's name this as line L. Okay, so what is given here? Okay, AB is the segment, or we can say line L is the, so line L, which is this line, is the perpendicular bisector of segment AB, okay, of segment AB, and M is the, what we can say, M is dividing AB. So we can say passing through M. Passing through M. Okay, so if it is passing through M, it is understood that AM is equal to BM. So we can write that in given itself. So AM is equal to BM. Okay, now this is to be proved. Okay, so let's see how we do it. So we have to prove that this and this should be equal. But if you have done triangles from the start, you know, if you want to prove these two sides, okay, PA and PB, to be congruent, what can we do? Try to prove that the triangles are congruent. Yes or no? These two triangles, if they are congruent, by CS/CT, corresponding sides of congruent triangles, we can say that this side and this side are congruent. Yes or no? So we'll take these two triangles and we'll try to prove that they are congruent. So let's see how we do the proof. Okay, so if you have understood how to do the proof, make sure that you write it on your own, okay, on the piece of paper you have taken, okay, and then cross check with what we are doing. So let's see. So let's consider in triangle PAM and triangle PBM. Okay, these two triangles. Now PM, okay, or you can say AM and BM, they both are congruent. So AM is congruent to BM. Why? Because given. So the reason will be given here. Yes or no? Same way. Now, can we say that this angle, if this is 90°, then this will also be 90°? Yes or no? Because this is forming a linear pair. So 90 and 90. Therefore, we can say angle PMA is congruent to angle PMB. Yes or no? Because each of them are 90°. So we can say each 90°. So this will be the reason. Now, can we say PM congruent to PM itself? Therefore, common side. Now you have understood how to prove that two triangles are congruent, okay? You take common side or 90° each, or you know what is given. So you take all of the data which is given, or you can get it from the figure, okay? And try to prove that the triangles are congruent. So here if you see SAS, therefore triangle PAM is congruent to triangle PBM by SAS test. Yes or no? So I hope you have understood how to prove two triangles congruent in this figure. Now what are we supposed to prove? PA should be equal to PB. Therefore we can say that PA is congruent to PB by CS CT. Okay, corresponding sides of congruent triangles. Okay, so this is the proof for this. I hope you have understood this. Okay, now the converse of this theorem. Okay, here this theorem said if there is a perpendicular bisector, then any point on the perpendicular bisector, which is let's say P, we have considered, that is equidistant from the endpoints. But here the converse says if any point on the line, okay, see, any point equidistant from the endpoint. So it is given that these two are congruent. First of all, these two are congruent, and we have to say that P lies on the perpendicular bisector. Okay, that's what converse says. So here this theorem said if P is on the perpendicular bisector, then it is at equal distance from the endpoints of the segment. But here this theorem says the converse. It says if any point on the line is at equal distance from the endpoints of the segment, then it lies on the perpendicular bisector. Okay, so that is the converse of it. That means we have to prove that P is on this perpendicular bisector, meaning on line L it is there. Okay, I hope you have understood this, what we are doing here in converse. This PA and PB, they are given as equal, they are given as congruent, and we have to say that P lies on this perpendicular bisector. Okay, so let's see how we do the proof for this. So here, okay, that's the theorem. Okay, it says that P is any point at equal distance from the endpoints of the segment, correct? And we have to say that this point P, it passes through the perpendicular bisector. So let's draw a perpendicular bisector through. Okay, so this is our construction which we are doing. So we'll write that in construction. What is to be proved? What is to be proved? That P lies on the perpendicular bisector. That P lies on perpendicular bisector. Correct? What is given to us? Okay. So what is given to us? That PA and PB, they are congruent. That is, P is a point which is at equal distance from the endpoints of the segment. So what is given here? P. See, it's written, right? Any point equidistant. So P is equidistant from the endpoints segment. Okay, that means PA and PB, they both are equal or congruent, you can say. Okay, so that is given to us. What is to be proved? P lies on perpendicular bisector. Now what we do a construction, we draw PM, okay, where M we take, okay, take M, okay, take M, any point, or you can say take M as the midpoint of, okay, so take M as the midpoint of segment AB. Okay, so we are taking M as the midpoint and draw PM, which is this PM. Okay, and we are extending this also, so this is our line. Let's name this as L. Okay, so we have done that in construction. We do not know whether this is a perpendicular bisector or not, but P, we have to prove that P is on perpendicular bisector. It's not necessary that P will be here at this point. It can be here or here somewhere. Okay, so it can be anywhere. So P is any point and we have to prove that it is on perpendicular bisector. So in order to prove that P is on perpendicular bisector, we need to prove that this line which we have constructed, okay, with the help of construction, which is draw PEM, we have drawn. So that should be a perpendicular bisector, which we need to prove. If we are able to prove that this line is a perpendicular bisector, then you can see P is on this perpendicular bisector. Yes or no? Therefore, let's try to prove that this line is a perpendicular bisector, meaning try to prove that PMB and PMA is 90 or both are 90. If we are able to prove that this is 90, then this line is a perpendicular bisector. Yes or no? So let's see the proof now. Okay, so the proof says, first of all, let's take these two triangles and try to prove that these two triangles are congruent. Okay, so in triangle PAM and triangle PBM. Okay, so what is given here? PA congruent to PB. Let's write that quickly, fatafat. Okay, whatever is given. So PA congruent to PB. Reason? Because it's given. And AM congruent to BM. Construction, because we have taken M as the midpoint in the construction, correct? Now, can we say PM is congruent to PM itself? So PM is congruent to PM. Why? Because common side. Yes or no? So with this S, S and S. Therefore, so by SSS test, these two triangles are congruent. Yes or no? Now, what can we do here? Now we can say, okay, this angle, they both are congruent. Yes or no? This angle, they both are congruent. And also, we can say that PMA and PMB, they are also congruent. Yes or no? So let's see. Okay, let's prove it. Angle PMA is congruent to angle PMB, corresponding angle of congruent triangles, correct? So these two angles we have got as congruent. Okay, now if you see, this is a linear pair, yes or no, like this, yes or no, this is a line and there is a linear pair. Therefore we can say that this angle plus this angle is equal to 180 degree, correct? So we can say angle PMA plus angle PBA MB equal to 180 degree. Yes or no? Why? Because angles in linear pair. So angles in linear pair. Yes or no? Now, if you see PMA and PMB, they both are congruent. So we can say this will be PMA plus PMB can be written as PMA. So PMA equal to 180. So both PMA plus PMA is 2 times angle PMA equal to 180. Therefore, PMA is equal to 90. Okay, so we have got PMA as 90 and PMB is also 90 because they both are equal. Okay, so with the help of this, we are getting these two angles to be 90 degree. So if this angle is 90 degree, that means line L is the perpendicular. Okay, perpendicular, but M is the midpoint. So here we'll also say here M is the midpoint of AB. Yes or no? Therefore MB is the perpendicular bisector. So we can say line L. Okay. Therefore line L is the perpendicular bisector of AB. Therefore we can say if this is a perpendicular bisector, if you remember, P is on the perpendicular bisector. So therefore we can say the last part, therefore P lies on perpendicular bisector. Okay, so I hope you have understood this. Okay, so what we did here to prove that P is lying on the perpendicular bisector, we took a construction which passes through P. Okay, which passes through P, any point P, and passing through the midpoint of AB, which is M, and we had to prove that this line is a perpendicular bisector which is passing through P. So if this line is a perpendicular bisector, then P lies on the perpendicular bisector. Correct? So I hope you have understood this, what we did, this proof. Now we have done with perpendicular bisector theorem. Now we'll take angle bisector theorem. Okay, so let's see. So here we are doing angle bisector theorem. Okay, so this theorem, it says that every point on the bisector. So first of all, angle bisector, you know that if you have an angle which is PQR, then QS is called angle bisector when this angle and this angle, they both are congruent. So if an angle, okay, is divided into equal part by a ray or a segment, then that ray or segment is called angle bisector. Correct? So bisector means it is dividing into equal parts. Angle bisector is dividing angle, which is this angle, into equal parts. So this angle and this angle, they both are equal. So that's what angle bisector is. Okay. Okay. So there is theorem based on this which says, okay, I hope you have understood what is angle bisector. Okay. Now every point on the bisector, so this is the bisector. Now every point, so every point meaning let's take at least one point. Okay, let's name that as A. Okay, so every point on the bisector, so this is the bisector, right, of an angle. So this is an angle and iska bisector is QS and A is on the bisector, so that will be is equidistant from the sides of the angle. Yes or no? So this is equidistant from the sides of the angle, meaning this and this. What are we supposed to prove? That this side, okay, the point on the bisector should be at equal distance. See, should be at equal distance from the sides. So from this and from this. So these two sides, let's name this as B and this as C. We have to prove that AB and AC should be congruent. Okay, that's what this asks to prove. So let's see what is to be proved. Let's write that to prove AB is congruent to AC. Okay, but we have drawn, if we have to find the distance, we always draw perpendicular distance, correct? Same way here also. So you should know whether this or this, you show 90 degree, it is both of them are 90 degree, correct? Now what are we supposed to prove? AB and AC should be congruent. So in order to prove this and this to be congruent, same way we can prove that these two triangles are congruent. Yes or no? If we are able to prove these two triangles congruent, okay, this and this, then we can say by CSCT these two sides are also congruent. Yes or no? Easy for us. Therefore, let's start. What is given here first of all? Let's write. Okay, so QS is the bisector. QS is the bisector of angle PQR. Correct? And A is on any point on the bisector. A is a point on the bisector. Okay, and also AB is perpendicular to PQ. Yes or no? Because distance, if we want to find, which is to find AB, we always take perpendicular distance towards this. So AB is perpendicular to PQ and AC is perpendicular to QR. Like we did in the first chapter, basic concepts in geometry. Okay, if there is a point and if you want to find the distance of this point between this line, we always take perpendicular distance. If you have, let's say, a line like this, and if you want to find distance between this line and this point, therefore we always take perpendicular distance. So here this way. Same way, to find distance between the bisector of any point to this side of the angle, we always take perpendicular from point A to PQ. So we take perpendicular here also and here also. Okay, so this is the concept from the first chapter. If you have forgotten, if you don't feel understanding, if you don't understand, so please go and check the video for that. Okay, so here we'll continue now. So this is given here. Now let's do the proof. So the proof says, okay, so we have to prove these two triangles. So we'll take in triangle QBA. So QBA and triangle QCA, correct? Now QBA is congruent to QCA. Why? Because each of them are 90 degree. Each 90 degree given. Yes or no? Because they both are perpendicular, so that's why they are 90 degree. That is given to us. Yes or no? Now this QS is the angle bisector. That means this angle and this angle, they are congruent. That is also given to us. Therefore we'll say angle BQA is congruent to CQA. Again given. Yes or no? Because QS is the angle bisector. Therefore QS, this line will divide this full angle into half, equal half. So that's why this and this angle are congruent. So we have written that. Now QA is congruent to QA. Why? Common side. Yes or no? Therefore by ASA test, we can say triangle QBA and triangle QCA, they both are congruent. correct, by ASA test, correct. Therefore, if these two triangles are congruent, we can say BA, okay, or we can say AB and AC, they are congruent by CSCT. Okay, so I hope you have understood this. Now we'll take the converse of this, which says, so this says that any point equidistant from sides of an angle. So there are sides of the angles, okay, and any point equidistant, meaning these two sides are equal given to us, okay. So any point equidistant from the sides of the angle then is on the perpendicular bisector. So we have to prove that, just like perpendicular bisector theorem, okay, we have to prove that A is on the bisector, okay. So we have to prove that. So we do not know whether this is a bisector or not. We have to prove that this is a bisector. So here we have to prove that A, this point A, is on the angle bisector, okay. So what is given here to us? So I hope you have understood what this says, okay. This says that A is any point on the sides of the angle which is at equal distance from both the sides, which is AB and AC, they are equal. It's given to us. So we'll say, okay, we'll say that AB and AC, they both are congruent. It is given to us already, okay. And this, okay, and we have to prove that A is lying on the perpendicular bisector or angle bisector, sorry. So we have to prove that A lies on angle bisector, correct. So okay, so A is any point at equal distance, okay, from this angle that is given. So we'll just take this, we'll just write what is given, okay. So A is any point okay. So A is any point of angle PQR and AB is perpendicular to PQ and AC is perpendicular to QR, correct, and AB is congruent to AC, and we have to prove that A lies on angle bisector. So let's draw, we'll do a construction of a line, okay. So we'll do a construction, draw a line from Q. So draw, okay, draw a ray from Q passing through point A. So if we want to prove that A, okay, is on the angle bisector, we need to prove that this line which we have joined, okay, this line which we have drawn here, this is an angle bisector. That means we have to prove that this angle and this angle, they both are congruent. That's what we need to prove ultimately, okay. So let's see how we prove them, okay. So again, the same way, we take these two triangles, okay, we try to prove them congruent, and if we are able to prove by CACT, we can prove that these two angles are also congruent, and then we can say that this A lies on angle bisector, okay. So I hope you are understanding what we are doing here in the proof. This AB and AC, they both are congruent, that is given, first thing. then 90 degree, 90 degree, ABQ and ACQ 90 degree, okay, that is also given, and AQ or QA, okay, QA is congruent to QA, common side. So by S test we can prove that these two triangles are congruent, and then by CACT these two angles are congruent. Okay, so we won't be writing the proof for this. I hope you have understood and you will be able to write the proof for this on your own. Okay, so I hope you have understood perpendicular bisector theorem and angle bisector theorem. Okay, so in the next video we will be continuing with this chapter, okay, and we'll be looking at theorems on inequalities of sides and angles, okay, of a triangle, okay, and also questions based on that theorem and the theorems which we did now, which is on perpendicular bisector and angle bisector theorem. Okay, so I hope you have understood the theorems which I taught you now. Okay, and if you have understood, make sure that you share it with your friends. Okay, thank you for watching.